Okay, so let's start the lecture. So, review. I'm going to review quickly the most important result of the previous lecture, which is about the miracle input. Let S be an LTI system, and G of n its impulse response. Then for all input x of n, we have the result that the response of S to x of n is the convolution between x and g, where the convolution is defined by sum of x of k g of n minus k. The student forgot his pen here. All right, so this is the very important theorem. So now to see if, as an application, I have this question. If S is LTI and we know its impulse response, question, do we know S? And you vote. Okay, this time, okay, let's vote. How many of you vote yes? How many of you vote no? Come on, the answer to this question was here. It was here. It's here, look. If you know S and if you know G of n, the impulse response, then you have this formula. You have the explicit formula of S. So obviously it's yes. So the one who said no is because you remember I asked the question previously in the previous lecture, and in the previous lecture, whoever said yes, I responded, are you silly? If S has no property, if you only know the impulse response, you know nothing about the system. But here, the system is LTI, and when the system is LTI and we know its impulse response, then we actually have the formula of the system. So we know the system. So let's write another question. Let S be LTI of impulse response G of n. And let consider another system, S prime, that is LTI also, and its impulse response is G prime of n. So clearly, if S and S prime are equal, obviously, they will give the same impulse response. But the question is, now my question is the converse true? Okay, let's vote. How many of you vote yes? How many of you vote no? You are extremely disappointing. You are extremely disappointing. Both S and S prime are LTI. So you can apply theorem 1. That means with G of n, with S, you get this formula, because S is LTI and G of n is the impulse response. For S prime, you can apply the same formula, but you're going to get G prime. S prime is this with G prime here. But we assume G equals G prime. So you end up having the same formula. You're going to get S prime of X is X convolved with G also, because G prime is G. So the two systems give the same formula. So obviously, yes. You see, I'm amazed that you are not able to. Did you see that there's almost no material here? It's purely logic. You see, and you're not getting this. So I think it's a reason why. I mean, you may hear that from the first midterm exam. It's like you get shock. Okay, you're going to get a shock, right? And I think a main reason why first midterm exams gives a very disastrous result is because of lack of logic. You don't follow the logic. You see here, it's so clear, right? So it's equivalent. For two LTI systems to be equal, it is necessary and sufficient that their impulse responses be equal. I told you, I mean, you know that once you know the impulse response, you know the system completely. So why with the same impulse response you are going to get a different system? If with the same impulse response you get two possible systems, then the answer to the previous question would be no. You see, it's pure logic, pure logic. All right. Next lecture, which will be next month, there will be a lecture which will be full of pure logic, and this is again where you get lost.
I have one question. So, for example, we can also say this is yes because it's LTI. It's like
Because of theorem 1, yes.
Yeah, because of that theorem.
Yeah. I mean, the explanation is there. It's all in theorem 1.
I was just asking.
Okay, next is going to be section 5 or 6, maybe 6. We are going to specialize in convolution. All right, so we're going to forget about LTI systems for a while, but we're going to focus on the formula of convolution, okay? Because since LTI systems will reappear until the end of semester, this convolution operation is going to be all over the place, and you must master the properties of convolution. So when you see z of n equals convolution between two sequences x and y, so you know that this is the sum of x of k, y shifted by k. But this means that for every n, z of n is the sum is this, all right? So this is the definition. So that the first thing about convolution is to know the definition. The second thing to know about convolution is the list of its properties. Okay. First property about convolution is that it is commutative. Do you know what that means? It means you can commute x and y when you perform a convolution. Proof. Who doesn't like proofs? All right, you don't like proofs because you don't like to understand, or because you are afraid to have them at the exam? Ah, okay. It's mainly because of exams, not because you don't want to understand. In fact, you want to understand, right? Yes. Okay, so, but anyway, who likes proofs? No, in the lecture. Who likes proofs? Who likes proofs? Oh, there are so many people who don't vote. They are afraid that I will shoot them if they say I don't like proofs, right? Let me tell you, proofs, as a student, I just wouldn't take a class which doesn't explain why things are like that. You see, I don't know about your approach, but as a student, I hated classes where you had just a list of facts and you don't know why. Just apply them. I mean, all right. I don't know the culture in this country, but in my country, there are two classes of people. You have the engineers and the technicians. Do you see what it's saying? Technicians are only asked to just apply, right? But engineers, it's a higher level, right? They are the designers, right? So to design, you really need to understand how things work, right? And why, okay? Not just how, but you need to know why, because when you know why, then you understand better how, okay? All right, but here I can see you don't like proofs, so I skip the proofs. Is that good news? Okay, I'm sorry. I decided to skip the proof of this. But anyway, you can try to prove it by yourself. What you need to do is remember, you will have to deal with summations. And then you have to remember from calculus how to perform change of variable in a summation. Do you remember to do that? You know how to do that in integrals, right? Summations are like integrals, okay? So you do that. But I'm skipping the proof, sorry, because it's too mechanical. But don't worry, I will give proofs on other properties that which are more crucial. It is also associative. So what does it mean, associative? This is a problem when you want to convolve when you want to convolve three sequences together. Okay, so here I'm putting a lot. Don't copy it. What I'm doing is that I'm going to put so when you have three sequences, you have to convolve them in some order. Like, for example, convolve this two first and then the third next, or convolve the last two first and convolve with the first one next. But then it doesn't matter because you get the same. You get the same result. So because you get the same result, we will write this without parentheses. Okay, since they give the same result, we can write without parentheses. Next, homogeneous. Convolution is homogeneous. So what does it mean? It is the case where you convolve two sequences, but eventually you scale this. It's going to give you the same thing as if you scale one of them and then convolve with the second one. But regardless of which one you scale, it's going to give the same. The next property is distributivity. Are you familiar with that? Yes, right? So distributivity is in the situation where you add the first two and then you convolve with the third one, and that gives the same result as if you same result as when you convolve z with x and y separately and then add the result. Now there's a notation. You can afford to write this without parentheses. If you omit parentheses, it will mean the same thing. It will mean the same thing as this, right? So the convention is that convolution precedes addition. Okay, no proof. Next, neutral element. What is the neutral element of addition? 0. What is the neutral element of multiplication? All right. Now convolution also has a neutral element. Can you guess it? Delta of n. You know the miracle input is a miracle, right? It does everything you want. If you convolve x with delta, nothing happens. Nothing happens. Okay, proof. this time. Remember that in the proof of theorem 1, we had two formulas, one formula on the input side and one formula on the output side. We had two formulas. We had two formulas, one on input side and one on output side. Now, do you remember on the input side, the formula? If you don't remember, I'm going to write it, and you tell me if it looks like what you saw. X of n was expressed as a sum of when k goes minus infinity to plus infinity of x of k delta of n minus k. Does it look like the formula we found? Yes. Now, look, what is this? It's nothing but x of n convolved with delta of n. So you do yes, and you do no. No, yes. Okay. No, you did yes. Okay. So what's next? Done. Okay, those who hate proofs, I don't know why. It's so nice. In 2 lines or 3 lines. Actually, you may say, no, I still don't understand. But I mean, we saw everything. We saw why this is true. We saw it, right? I have another property that is called time shift 1 property. This property says if you convolve x of n with shifted delta, okay, can you guess? Oh, you studied that before. Yeah, like in 205? No? Or is it because you, or maybe you studied my lecture beforehand? Oh, wow. Wow, some students are very serious. Nice. Nice. Okay, this time I'm going to give you a proof that is like mathematics. So what I'm going to do is that I'm going to call this y of n, and then derive y of n. So let y of n be this sequence. And let's derive what it is and see that it's equal to x of n minus n naught. So this implies that for every n, y of n equals the sum of x of k delta of I don't know what to write here. N minus n naught minus k. Are you sure? So I'm going to pretend I'm not sure. Yeah, I have to pretend. I'm going to pretend that I'm not sure. So what I'm going to do is that, okay, in details, y of n is I write y of n is x of n convolved with v of n, where v of n is equal to delta of n minus n naught. I can write that, right? And then, so then y of n is sum of x of k v of n minus k. When you write this, you know that you are not making any mistake. But v of n is delta of n minus n naught for all n. So what is v of n minus k? Yes. So I prefer this answer. You said previously n minus n naught minus k, which is the same thing. But I prefer this answer because this is what you get originally. So in fact, the answer is you get n minus k minus n naught. All right. Now, you want to expand this. So, but delta, how much is delta of n minus k minus n naught? So I'm going to write something. So you have to see the following: is that you have to n naught is fixed, but you have to consider that n is fixed also, and you perform this summation over k. So k is moving from minus infinity to plus infinity, and for each value of k, this is going to give you a different value. All right. So this is going to have various values depending on k. Okay, where n and n naught are taken fixed. You get this. So I want to know, but we know that this is going to be 0 or 1. But the goal is to find for which k is going to be 0 and for which k this is going to be 1. So to help you, I'm going to write something genius. Isn't that genius? No? Oh. No, but you're going to see it. When you write it this way, it's going to make it much easier to answer the question, because I know it's going to be 0, 1, but I want to know for what value of k this is 0 and what value of k this is 1. All right, so you say, somebody says here, what value of k? Yeah? Yes. In this form, it makes it much easier to understand this, right? That's why I say it's genius. Because you know that this is going to be 1 when inside it's 0. But this is going to be 0 only when k is equal to this guy. Okay? All right. So then I realize I don't have to perform this summation for all k's, because most of the time you're going to get 0. So you can limit the summation to what value of k? To the value n minus n naught, right? I'm going to write something stupid. I say summation from n minus n naught to n minus n naught. I can write this, right? It's right? All right, now this summation is easy to calculate because there's only one term. It is when k equals n minus n naught. So you get, what do you get? You get x of n minus n naught times 1. because this is the case when this is 1. So this is what you get. What's next? You know your lesson. Although I have to say that sometimes I see students who write down at the exam, although it's only halfway. They try to deceive me. I sit down, oh, good. No, students they are smarter than that. What they do is that they start at the beginning and then they get stuck, and then they start from the end. They get stuck, they glue them, and they don't show that they skip steps. So I read, I say, oh, it's fine. But no, I don't get deceived. I don't get tricked. I don't get tricked. Oh, by the way, I have to say something. When you copy, I don't have to watch you copying to know that you are copying just by reading the answer. I prefer to say that in advance because some students had big surprise in the last semester. Because typically a student who copies, he only copies a few things, and what they write is not consistent. So, because this class is extremely based on the reasoning. You know, for example, when I asked you to vote, many of you couldn't make it, but the right answer is extremely based on how you perform your reasoning. So, okay, when you make a pure mistake for reasoning, then I just take it as a mistake. But sometimes some students, they copy equations. And then that is easy to see when you copy. All right. This is time shift 1. Now you're going to say, well, didn't we see previously formula similar to this, except that we didn't have convolution, we had multiplication. Remember? So let's recapitulate. Let's recapitulate what we saw before and what we are seeing now. What's the difference? So I'm going to write down here what we just got. But what we had previously were similar formulas, but we didn't have convolution. Instead, we had what? We had multiplication. But what was the result? What was the result of this? Yeah, so what is the constant? Times what? What about here? Do you see that they are different? Now, students they always get mixed up between these two formulas, but there's no reason to get mixed up because you know on the left side, when you multiply a sequence by an impulse, you cannot get more than an impulse. And on the right side, it's from the neutral element property. When you convolve x with delta, nothing happens. It's easy to remember that. And this is okay, so there's a time shift involved here. But we have yet another property which is called time shift 2. which is as follows. Suppose that z of n is the convolution between x and y. So what is going to be the expression for z of n shifted by n naught? No, I would like a final answer that is concise, like already simplified. Simplified. Not both? Not both? Okay, let's vote. Okay, so okay, I'm going to write several answers and then you vote. Okay, so let me write as the first answer. This? No. What am I doing? This is wrong. This. And second answer. So we're going to propose 4 answers. This one alone is true, this one alone is true, this one alone is true, or these 2 together are true. All right, so we're going to vote in this way. How many of you vote that this one alone is true? Remember, being a minority in my class is good. How many of you vote this one alone is true? How many of you vote this one alone is true? How many of you vote that these 2 together are true? Let me tell you what I think. Look. I'm bothered by this one because if I were x of n, I would be jealous. Yeah, I will say, why not me? Why you? Why am I having this reaction? You saw that convolution is kind of symmetric, right? So one doesn't have one of the 2 factors doesn't have a more important role than the other one. So I would be bothered by this, right? This one is symmetric, so I'm not bothered in the same way, all right? All right, so I'm going to pretend I don't know the answer. So I'm going to derive it. So we know from time shift 1 that is the same thing as z of n convolved with delta of n minus n naught. Now z of n is equal to this, so I'm replacing that. Here. And then what property do you feel like do you feel like using now? No? Yes? So you get this. And then what property? Time shift 1 again. Time shift 1 for this one. So you get x of n. You actually get this one, the second one. So you get the second one. So the second one is actually valid. But if the second one is valid, there's a high chance that the first one is valid also. So how to prove that? The way to, I could restart this, but I prefer to use another original proof, which is to write that by commutativity, I also have, so I also have I have commuted. I can commute these two. Now I have used commutativity, and since I know that when you shift z, it's the same thing as shifting the second one. Here the second one is x, so I'm saying that I know that you are going to get the same thing as y shifted convolved with x or n minus n naught. And then what property do you feel like using? Commutativity again, right? And then you get you finally get this. So you end up proving both of this. All right, so this is the answer, and we are done here. All right, so you have all these properties which you must know perfectly to answer certain problems on convolution. But then the third part of this lecture is that there's a third aspect of convolution that you should master, is how to compute convolution graphically. So example, we're going to consider as an example, plot this convolution where x of n is the following sequence. So let's say 1, 2, 1. One, two, one. And then y of n, hello? And y of n is my usual favorite sequence, which becomes C3 and then 4. All right, so there's a trick. We know that for each n, z of n is x of k, y of n minus k. Now the trick is as follows, is to express this in terms of x of k and y tilde, but I don't know what to write here. I hesitate between writing minus n minus k and then minus n plus k. Okay, how many? Let's vote between this. How many of you vote the first one is correct? How many of you vote the second one is correct? You know that y tilde of p is y of minus p, right? So if you write y tilde of minus n minus k, what do you get? Y of n plus k, and this is not what we want. What we want, and if you write y tilde of minus n plus k, what do you get? Y of n minus k. This is what we want. So the answer is the second one. So the majority wins. So I can write k minus n. K minus n. Okay, why do we use this trick? This is because, let's say, what is z of 0? It's going to be just this. What's happening here? You see this operation? It has a name. This is called an inner product. However, the term inner product, you don't seem to be familiar with this, so I'm going to use a term that is less correct, but it's more commonly used. Dot product. Yeah, now I see. But dot product is used for like vectors. Isn't that similar? The only difference is that with vectors, you only have like a finite number of coordinates. You see, with the dot product between two vectors has this formula where the summation is over all coordinates, right? You know that. This one is similar, except that the number of coordinates is infinite. Okay? A sequence is like a vector with an infinite number of coordinates. So it's nice to put in this form because at 0, you just have the dot product between two sequences, x of k and y tilde of k. So, so the trick is to plot x and y in terms of k. Uh, so I'm going to replot them, but I'm just going to change the you know, n is a dummy variable. You can choose any name you want, provided that you are consistent with your name. So if you call it k, you must have k here. That's it. Okay. And then you can plot. So let's see. I want to make sure I have enough space. Maybe not. What I'm going to do is I'm going to miniaturize this. Can you still see? Oh, it's so big here. I can even miniaturize more. Yeah? Tiny, tiny. But then we want to I mean, this display is amazing. This is the one of the rare things that works well. Don't repeat. Don't repeat that video. All right, so I have the flip version of y, and then you can start doing the inner product. So the dot product, if you prefer that expression. And what do you find? So you find equals. So can you do it? So here we have -2. So at -2, you still have 0. At -1, you get 0. You still have 0. And at 0, you get 3. At 1, you get 8. And then after that, you get 0 again. So you get 11. So you get the value of z at 0 equals 11. So guess what? We can plot z of n right away at 0. And at 0, we get 11. And this is the beginning of the plot of z of n. And you get partial credit. Right? I didn't hear if you put what?
No matter what function you give, exactly the same way. So
let's put it this way: when the partial credit is less than a quarter of point, it becomes 0. So if you get if it's a quarter of point, then it becomes quarter of point. But below that, it's I just neglect. So we do approximations. But how to get z of 1? Z of 1 is going to be this formula. Z of 1. All right? So it's going to be the dot product, but not between x and y tilde, but x and the shifted version of y tilde by 1. So what you do is you plot y tilde shifted by 1. And then you perform again this dot product. And what do you find? You're going to find so only at 0 you get so you get 2 plus 6 plus 4. That gave 12. So you're happy. You want to get more partial credit, and you do that. But I'm not going to rewrite what is. Do you want me to write this? What is okay? Let me do it. Here, at 2, you are going to have you are going to involve the shifted version of y tilde by 2 to the right. And let me not plot it. You know, you can start doing that mentally. You look at y tilde of k. You say, when you shift this by 2, this guy falls here, and then you're going to get 1 times 1. And this one falls here, you get 2 times 2, so it's 4. This guy falls here, you get 3 times 1, which is 3. And then you get 0 after that. And then you find 8. Now, 0, 3, I'm not going to write what it is. You shift also mentally. So you get this one, you shift it by 3, so this guy will come here. It's 1 times 2, so you get 2. This guy arrive here. 2 times 1 is 2, so you get 4. And it's not finished actually, so we need to move. Oh. Z of 4 is what? Z of 4, that you need to shift this by 4, so this minus 2 is here. You're going to find 1. You're going to find 1, all right? So you get 1 here. Sorry, the scale is not so good. But then you get 0 then, right? But we're not done, because we still have to look at the negative shift. So Z of minus 1, what is Z of minus 1? Right. So this time you need to shift y by 1 to the left, and then you're going to see that you get 1 times 4 here, and that's it. So you get you get 4. And at minus 2, what do you get? Yes. And you are done. Now, at an exam, you don't have to show all these multiplications. If you can do all this calculation mentally, I accept it, as long as in the end the numbers are right. Okay, so typically at an exam you may not even plot the shifted version of y. You just plot the y tilde. You just plot y tilde okay, and from there you can do your dot products with and shift mentally y tilde okay, and you may not even need to write all these numbers. I mean, I still see students writing everything like very long, but let me tell you, the faster you can go, the better, because then you can answer more questions. All right, so if you are slow, then you, in a way, you penalize yourself. Okay, it's up to you. Now, you could even become even stronger by just not even plotting y tilde okay. You do the flip in your mind, and then you do all the shift, all right? So in the end, I can say, I give you x and y, what is the convolution? And then you just look at this and you say 11, 12, 8, 4, 1, 0, like that. So when you become champions of convolution, hopefully within 2 weeks, right? When you're gonna know? All right, so, okay. So, about convolution, you have to know 3 things: the original definition, all the properties, and graphical computation. And for each question involving convolution, only one of the 3, one of the 3 is the best way to answer the question. It may not be the original definition, it could be a property, it could be a graphical computation. Every time you have to figure out which method is the best. Now I can move on to the next paragraph. All right. So until now, you may say, this class, I don't like it. It's supposed to be engineering, but what the professor does is only math all the time. Math, logic, abstract, math, logic, abstract. Is that how you feel?
Sounds like every engineering class.
What?
Sounds like every engineering class. Only math and yeah, that's
Okay, you make me feel better. But anyways, if some of you complain, what is he doing? It's just math. Then I will say, okay, take it easy. Here's section 7. Section 7. I'm going to write a word that is going to make you feel better. Can you read this? Does it sound like engineering? Absolutely. If I say building, it's like, wow, engineering stuff. Right? Building. Constructing, you know? That's what you imagine of an engineer, right? You want to be builders, no? Or you want to be just thinkers like me? Okay, but before we start building LTI systems, we still need to resolve something. Because until now, what we know is that if I give you a system, you have the ability to check the property of the system, whether it is linear, whether it is time invariant. And if you are given a system that is already LTI, then you know what to do with this. You have certain properties, you have convolution. But we still don't know how to make an LTI system by ourselves, right? So if you are given an LTI system, you say, oh, it's LTI, okay, let me take it, I will use it. Yeah, but now it is, some companies, they do that. They just don't know how to make things, so they open other people's circuit and they look inside and they redo it the same way, cheaper. Okay. I will not tell you what country does that. Let's remain politically correct. All right. So actually, this type of thing is actually illegal to do in the US. All right. So, no. We want to have the, what do you call, the know-how. So you want to know how to build all possible LTI systems. What is the whole pool of possible LTI systems you can have, and then you will know exactly what is the optimal system you can find, because you know all the possibilities. So we still need to answer this question. All right, you get it? All right. So I'm sorry, there's going to be still going to be some math. All right. So convention. Let h of n be a given sequence. By convention, this, if you write a box with the name of h of n inside, this symbolize the system S such that S of x of n is equal to h of n convolved with x of n. I'm not talking yet about LTI systems. What I assume is that we know what is the definition of convolution. All right, we have defined it. And from one given sequence h of n, I make this system. It's a system because I'm giving the formula of the system. All right, so it's a system. Okay? So, so in other words, when you input x into this system, by definition of that system, the output is the convolution between x and h. All right, so this is, whenever you see a symbol like that, you understand that it means that. So don't ask me, oh, what do I assume? I'm not assuming anything. It designates this system. So now we have a theorem which I call theorem 2. It says two things. It says the following: this system is automatically LTI. Second, the impulse response of this system is automatically equal to h of n. I'm going to prove that. I mean, those who don't like proof, sorry, proof. But I'm going to prove property 2 first because it goes really fast. And we'll do property 1 later. What is the impulse response of a system? No, wrong. Delta of n is the impulse sequence. Hey, you forgot. The impulse. The impulse, yes. You forgot that impulse response means impulse response. You forgot that. It's not difficult to remember, right? Impulse response means impulse response. You should be able to remember that, no? I know your memory is very limited, but all right. So impulse response, that means what? That means you get the impulse response by inputting delta of n into that system. And the impulse response is what you get here, right? Is the output. You said that, right? Output. This is what you get here. Now, by construction, by definition of the system, what do you get here? You get this. But what do you say about this? Why? Neutral element. Conclusion, H of n is the impulse response. So next is property 1. But we don't have time to prove it in this lecture. We'll have to do it next. Yeah, in 1 month. Fantastic. I love that. Okay, you owe me something.